Okay, so another important operator we have introduced in the relational algebra is called joins. So given two relations R and S, we can calculate the join between them, right? Here we don't differentiate the natural join or equijoin. Here we just assume we have a join operator between relation R and S. So here this R denotes one relation, and we can also call it as outer relation. As S denotes another relation, we can call it as inner relation. If you still remember how we calculate the joins between two relations, right? Normally we have enumerate all the tuples in these two relations to check if they can be joined together or not. If so, then we can generate the output. Otherwise, we have to go over all the tuples, pairwise tuples between these two relations. So this operation will be very costly, right? Because we have to calculate the product between those two relations and then do a selection, something like that. Right? Here we show you with the example, how we implement its joins between relation R and S. So normally we have to enumerate all the tuples in R in the capital R relation, and inside this for loop we'll have also to enumerate all the tuples in the S relation as well. We can check if tuple R and tuple S are joinable or not. If so, then we can generate the output for the result, right? So you can see the cost of this operation will be very costly. It depends on the size of R and S actually. So normally, the cost for this operation will be about TR and TS. It depends on how many number of tuples we have in R as well as, right? However, sometimes we can also define cost to be TR times BS instead, because sometimes if this S is clustered, and we can check each block of S to see if its R is joinable with the block or not. In other words, the cost can be reduced to the TR times BS instead. Okay, so this is the nested loop join, so we can implement with the one-pass algorithm. And in this algorithm, normally we assume, we are doing based on tuples because we enumerate all the tuples in the relation R and S, right? So the cost will be based on the tuples actually. Besides the tuple-based joins, we can also do another join. It is based on blocks instead. What does this mean? So here, we enumerate all the blocks of a relation first. We have each block of a relation. It can be denoted by BS for this S relation. And we can enumerate all the blocks BR of this R relation. And inside these blocks, we can further for checking each tuples in the BS as well as each tuple in the R in the BR this block. And we can compare if R and S are joinable or not. If so, we can generate the output. Otherwise, we will continue with the remaining tuples instead. Compared with the previous one, for the previous one, we have to load all the tuples into the memory, right? It is a tuple-based operator or the algorithm. If we do it based on the blocks, in other words, for each time we have to enumerate one block actually. We just need to load one block BS and one block BR into the memory, and then we can enumerate based on this tuples inside these loaded blocks instead. In other words, the time cost will be relatively lower compared with the previous one, right? So normally we have two relations R and S, right? And both of them they will have multiple blocks stored in the disk on the disk, and then we can load them into the memory. And here we show the algorithm. In other words, we load all the blocks of S into the memory. We load all the blocks for S into the memory, and we have assumption that this number of blocks in S is smaller than the memory size. And we also deal one buffer in the memory for the R, for the block in the R. In other words, enumerate all the blocks in the R one by one into the memory, and we can compare them together to do the joins between them, and also generate the result. According to this diagram, we show that we have some assumption. First of all, we need to assume that the size of S is no greater than the memory size minus 1, right? And we also enumerate all the blocks in R, this relation. In other words, we have to do the joins for all the blocks in R. Then we have to run this algorithm multiple times, right, in the real-world implementations. Then the cost for the blocks-based joins actually is very different from compared with the tuple-based joins. So, when we do the block-based joins with the previous diagram, the cost will be about, when we read this S, and we have to read it only once, right, the cost will be about BS, the number of blocks in the S relation, right? As to the outer loop, we have to enumerate all the blocks in the S. It will run, BS divided by M minus 1. It really depends if this side of the BS is smaller than M minus 1. In other words, we have to run the outer loop only once, right? If this BS size is larger than m minus 1, we have to load multiple times actually. So here we assume this BS is smaller than m minus 1. In other words, we have to run the auto loop only once, right? And then for each of the auto loop, we have to load one record from this R, right? Or one block from this R. In other words, time cost for the whole algorithm will be about BS times BR divided by m minus 1. If we assume this BS is smaller than m minus 1, then the cost will be about BR, right? It really depends on how many blocks we have in the R relation. As to the total cost for loading both S and R, then we can denote it as BS plus BS times BR divided by m minus 1. If BS is much smaller than m minus 1, the cost will be about BS plus BR, right? It will be much smaller than the tuple-based joins we showed before, which is BS times BR, which is much larger than this one, right? Normally, we need to ensure this BS is much smaller than m minus 1. In other words, it will be better to iterate over the smaller relation, this S. If this S is smaller, then we can ensure this BS divided by m minus 1 will be equals to 1, right? Or smaller than 1. In other words, we only need to load it once, and we can ensure the algorithm will be implemented in a much efficient way. Okay, so this is about loop joins. We can implement with one parse algorithm, and we have some cost denoted by in this page. We will show you how to do these joins based on both tuples and with blocks. They will introduce very different costs actually in the implementations.